All right, welcome back. So this is a continuation of our polar unit. We're actually still working in section 8.5. It's got a lot of information there for us. And we're going to take the information that we know about our coordinates and the relationship between our x, y, and our r theta as we try to now convert between different types of equations. So here's our just a little bit of review for us. X is equal to r cosine of theta. Y is equal to r sine of theta. R is written in the form of the square root of x squared plus y squared. And the tangent of theta is the ratio of y over x. If we remember this as we try to convert, then converting it into these rectangular equations, or polar and rectangular equations, shouldn't be tricky. So we're going to be using a lot of substitution here. So you'll find it very similar to the identities chapter, except we only have those 4 relationships. That's it. There are no others. So as we work here, I want to eliminate all r's and all values of theta and replace them with what we know about x and y. To do this, I recognize that I have an r and I have a sine of theta, but they're actually not together. So I'm going to work to put them together so that they actually have that connection of r sine of theta, which we know. So since you have it on the top of your page, and I want to be able to reference it on here, but we know that r equals the square root of x squared plus y squared, that the tangent of theta equals y over x, x equals r cosine of theta, and y equals r sine of theta. So those are the things I'm going to use as I complete this. The first trick I'm going to use here, or method of solving, is I'm going to multiply both sides by this denominator. So if I multiply both sides by 1 plus the r sine, or 1 plus sine of theta, and on this side 1 plus sine of theta, I will have r times 1 plus sine of theta, and this side will equal 4. I'm going to distribute the r because I want the r next to the sine of theta. That will give me 1 times r is r plus r sine of theta equals 4. Now since my goal was to get rid of the r's and thetas and replace them with values of x and y, I know that r is actually equal to the square root of x squared plus y squared, and r sine of theta can be replaced with just a y equals 4. To simplify this further, so we can put it into something that would actually be useful when we graph it, is that I want to subtract the y to the other side, leaving me with x, the square root of x squared plus y squared equals 4 minus y. To get rid of the square root, I'm now going to square both sides. I'm going to change color so you can see where I'm going with this now. So I'm going to square both sides, and that will result in just x squared plus y squared. And on this side, I'm actually doing 4 minus y times 4 minus y. And that will give me 16 minus 8y plus y squared. Since I have x or y squareds on both sides, and they're the same positive, then I can get rid of them, and my final answer is x squared equals 16 minus 8y. You may or may not remember this, but this is actually a parabola. It's a parabola that opens sideways from your conics unit, which was the last unit from Algebra 2. All right, example number 2 is going to be handled a little bit differently. I have a sine and a cosine, and I have an r, but I don't have a denominator, so I can't use the same approach I did in the first example. So for this one, I'm going to begin by actually just multiplying both sides by r. Oops, I should have put that parenthesis somewhere else. It should have been around the whole thing. So I'm going to multiply both sides by r. This side will turn into r squared, and the other side, when I distribute the r, is r sine of theta plus r cosine of theta. Perfect! I know what r squared is. R squared is equal to x squared plus y squared. And r sine of theta and r cosine of theta are exactly what I'm looking for up above, y plus x. Well, this is actually going to be a circle if we were to continue to graph it. I'm not going to actually ask you to put it into a form that looks like a circle, but if both x and y are both squared and the coefficients, meaning the numbers in front of them, are the same, then this is actually a circle. And we can actually leave this one right here, and we'll leave that one right there. Let's try converting the other direction. So for example 3, I have 3x plus 2y equals 4, and that is a form of a line, in standard form actually. So to do this one, again, I want to use our relationships. X equals r cosine of theta, y equals r sine of theta, and that's pretty much the two I'm going to be using because I'm going towards getting x and theta, or r and theta, and I don't want x's and y's, so I don't even need the other two formulas. So if I'm replacing x here with r cosine of theta, I have 3r cosine of theta plus 2r sine of theta equals 4. When we convert to polar form, we want to get r by itself most often. So I'm going to factor out the r, leaving me with 3 cosine of theta plus 2 sine of theta equals 4. And I'll divide both sides by that long quantity, so I will have r equals 4 over 3 cosine of theta plus 2 sine of theta. And that would be my final answer. And this is actually the polar form of a line. All right, let's try example number 4. This should be very familiar to you. Y equals x squared is a typical parabola. It's actually your parent function parabola for a parabola that opens vertically. So since y is equal to r sine of theta and x is equal to r cosine of theta, but we're squaring it, so I will have r squared cosine squared of theta. And the only thing we can do with this, because factoring out an r here won't actually help solve it, is we want everything on one side. So we'd have r sine of theta minus r squared cosine squared of theta equals 0 when I subtract that over. And that is a form of a parabola in polar form. That was actually it here. So give me just a moment here and we'll just recap everything that we did so we know that what our expectations are as we come to class the next time. And that is, we know that we're using our 4 formulas. So x is r cosine of theta, y is r sine of theta, r is equal to the square root of x squared plus y squared. We also, in one of those situations, we ended up using r squared equals x squared plus y squared without the square root. So we do want to be familiar with when it's appropriate to replace with one versus the other. And that the tangent equals the ratio of y over x. When we're converting from polar to rectangular, we want to eliminate all of, so we want to leave in terms of x and y. But when we go from rectangular to polar, then we want to leave in terms of r and theta. So the goal is, if it tells you to leave it in polar, make sure you're representing everything in polar information. And if it tells you to leave it in terms of rectangular equation, then you want to make sure that there are no signs of any polar business going on. That's it. Give those problems a try, and we will talk again in class.